Hello, my name is Regina Rodiguero, and today I will be presenting the triangle medians and centroids. First, we will take a look at the lesson overview. First, we will look at what are triangle medians, then what are the properties of a centroid and what a centroid means, and then how to find the median and centroid of a triangle, and then we will take a look at a couple examples. So to begin, what are the medians of a triangle? A median of a triangle is a line segment joining a vertex to the midpoint of the opposing side. As you can see, we have a triangle right here, and here is a vertex, which will be joined to the midpoint of this opposing side. The midpoint is the center of a line segment, or in this case, a side of a triangle, which means that it will be equal in distance from this side and from this vertex and this vertex. So as you can see, our midpoint is right here. We can connect this with a line segment, which will be called a median. We can also do this with this vertex right here and this midpoint over here, and this line segment, which is also a median. With this vertex, this midpoint, and a median. This center point right here is called a centroid, and it is the point of intersection between all three medians. Now we can take a look at an example of three more medians on a triangle. So here we have triangle XYZ, and we have the vertex Z right here, which will be connected to the midpoint over here. As you can see, the median is already drawn in. And then over here, we have, again, triangle XYZ, and vertex X, or vertex Y, sorry, and midpoint right here. And then again, on triangle XYZ, we have vertex X, which is connected to the midpoint right here. Again, the midpoint is equal in distance from each vertices. So for line segment ZY, it will be split in half or divided in half, and that point will be called the midpoint. So what are the properties of a centroid, and what is a centroid? The centroid of a triangle is the point of intersection of the three medians of the triangle. The properties of a centroid. It is located at the point of intersection for the medians. It is one of a triangle's concurrent points, and the centroid will always be 2/3 of the way along any given median and will divide the median in a ratio of 2:1. The centroid can also be found using this equation. So, a triangle with the vertices at x1, y1, x2, y2, x3, y3 will have a centroid at x1 plus y1 plus, x1 plus x2 plus x3 divided by 3, and y1 plus y2 plus y3 divided by 3. So now we can look at how to find this. So in this example, we are going to start by connecting the vertices and midpoints with line segments. The medians all intersect at one point, which is the centroid. So here we have vertex A, and we have our triangle side BC, or line segment BC, which is 8 centimeters long. Half of 8 centimeters is 4 centimeters. So the midpoint will be located 4 centimeters from B and 4 centimeters from C. Here you can see the median connecting the vertex to the midpoint right here, which is again equal in distance from B and C. So for vertex B, the midpoint will be connected. The midpoint will be connected to the vertex B, and since line segment AC is 9 centimeters long, the midpoint will be located at 4.5 centimeters from A and 4.5 centimeters from C. So in the case of vertex C, the median will be connected to the midpoint right here. And since this line segment AB is 6 centimeters long, 6 centimeters divided in half is 3 centimeters. So the midpoint will be 3 centimeters from A and 3 centimeters from B. This point of intersection right here is called the centroid. So now that we've taken a look at how to find the median and the centroid of a triangle, we can take a look at a few more examples. So in this example, we are going to be using a triangle with the coordinates -4, -2, 2, 2, and 6, -2. So we are going to use this equation and we are going to use this equation to calculate the coordinates of the centroid. So when we put in these values, x1, -4, x2, 2, and x3, 6, divided by 3, and then we will put in the y values, -2 plus 2 plus -2 divided by 3. -4 plus 2 is -2, plus 6 is 4. So we will have 4 over 3. And then -2 plus 2 is 0, plus -2 is -2 over 3. So when we look at these coordinates, so that would be x, which is 1 1/3, and y, which is -2/3, you can see that our centroid is right here, and the medians for this are already drawn in and connecting the vertex to the midpoint. And so as we can see, this equation brings our centroid to right here, which is correct, since all the medians intersect at this point. So let's take a look at a few more examples. Here is a right triangle with a side 5 centimeters long, 10 centimeters long, and 12 centimeters long. If we draw in our median right here and connect the vertex to the midpoint, which is 5 centimeters from each vertex, we can see that there's this median, and then for the right angle right here, when we draw in the median, it can connect to the midpoint right here, which is 6 centimeters from each vertex. And for this vertex right here, we will connect it to the midpoint over here, which is 2.5 centimeters from each vertex. Here is the point of intersection, which is the centroid. And then for this triangle right here, we have a side that is 7 centimeters long. Again, 7 centimeters long, and 10 centimeters long. So we will start with the vertex right here and connect it to the midpoint. As you can see, it is 5 centimeters from either side. And then we will start with the vertex right here, connected to the midpoint over here, 3.5 centimeters from each side. And the vertex right here, again, 3.5 centimeters, the midpoint is from each side. So now we can take a look at another triangle right here. So this vertex is at -1x and 3y. This vertex is at 4, -2. And this vertex is at -3, -2. So when we put these into the equation, we get -1 plus 4 plus -3 divided by 3, which would be 1 plus 4. -1 plus 4 is 3 plus -3, which is 0 divided by 3, or 0 over 3. And then when we plug in the y values, it is 3 plus -2, which is 1, plus negative 2, which is negative 1, and negative 1 divided by 3 is negative 1 over 3. So we have our centroid at 0, negative 1/3. So when we draw our medians in, we can see that they all intersect at 0, negative 1/3, which would be our centroid. Now, our final example right here, we see that we have another triangle at the points negative 1/2, 3, negative 4, negative 2, 3, negative 2. And we can see that these are 8.5 centimeters on each side and 10 centimeters. And when we draw our medians in, we can see that they all intersect at this point right here, which would be negative 1/2, negative 1/3. To verify this, we can look at our equation. So we can put in the values negative 1/2 plus 3 plus negative 4 divided by 3, and put in the values 3 plus negative 2 plus negative 2 divided by 3. Now, negative 1/2 plus 3 would be 2.5 plus negative 4, which would be negative 1/2, and then 3 plus negative 2 is 1, plus negative 2 is negative 1, so that would be negative 1/3 negative 1 divided by 3 would be negative 1/3. So we can see that our centroid with the 3 medians, the point of intersection for the 3 medians is correct, and it is the centroid because, as this equation says, negative 1/2 x and negative 1/3 y, which is the location of intersection. Thank you very much for watching. I hope you enjoyed this video and learned what the medians and the centroid of a triangle is. Thank you for watching.